Problem 1, decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would the constant of proportionality be? So problem number 1 says how loud a sound is depending on how far away you are. So if you look in the table, you have your distance to the listener in feet versus your sound level in decibels. So decibels are a measurement of sound waves. All right, so we always want to take the right side of the table and divide it by the left side of the table. So we have our decibels. So 85 decibels divided by 5 feet from the listener, you're going to get 17. So you're going to get 17. Now we're going to do that comparison again for the other rows in the table, and let's see what we get. As we're doing this, you can see that from the second row, there's already a different value. There is no constant of proportionality because you go from 17 decibels per feet, that would be per 1 foot, and then the next one is 7.9 decibels per 1 foot. So it's not a proportional relationship for problem number 1. All right, problem number 2, if we're looking at the cost of fountain drinks at Hot Dog Hut. Sorry, let's go back to problem 1, not proportional, and that's because 17 is not equal to 7.9. All right, back to problem 2. The cost of fountain drinks at Hot Dog Hut. We're going to divide the cost by the volume. Doing the same thing. The right side, cost divided by the left side, volume. If you do that, you're going to get 0.093. If you round it to the nearest thousandth, let's test the next row, see what happens. Just looking at the next row, it's actually 0.0795. But it's already different. It's not equal to the first row. So again, it's not proportional because the cost divided by the volume is not consistent. And what this language means right here, when we write it that way, this is the not equal sign, and these two values clearly are not equal to each other. All right, a taxi service charges $1 for the first tenth of a mile, and then 10 cents for each additional tenth of a mile after that. So we're going to fill in the table with the missing info. Then we're going to determine whether or not this relationship between the distance traveled and price of the trip is a proportional relationship. So to figure out the price in dollars, just like the story says, they charge $1 for the first tenth of a mile. So if we have 9 tenths right there, so the first tenth is $1, right? So that's 1 tenth. But then we add another 8 tenths, right? Because 8 tenths plus 1 tenth is 9 tenths. So let's add those. And I'm just going to show the shorthand. If I add 1 tenth plus 1 tenth plus, and I keep going, that would add up to 8 tenths. And then the 8 tenths plus the 1 more tenth, that's what gives you 9 tenths, right? On the top, you have your original dollar for the first tenth of a mile. And then if you add 10 cents plus 10 cents and you keep on adding, that's going to be an extra 80 cents. So that gives you $1 plus 80 cents, which is $1.80. All right, now if I want to reach 2 is equal to 9 tenths plus an extra 1 and 1 tenth, right? Because that 1 tenth plus 9 tenths, that's going to be 1 whole, plus the extra 1 right there, and that's going to give me 2. So if I add 1 and 1 tenth, that's going to be 10 tenths plus an extra 1 tenth, right? Well, we know that for 1 tenth, that's 10 cents. So that's like saying 10 cents times 10, which is another $1, right? So we got another $1 plus 1 tenth, that's another 10 cents, and that's $1.10 more than what we already had. Well, we already had $1.80, so $1.10 plus $1.80 is equal to $2.90. So I filled that in the table as well. Okay, so for our next section, 3 and 1 tenth, that's another 1 and 1 tenth extra, right? So 3 is equal to 2 plus 1 1/10. But we just figured out that 1 1/10 was an extra $1.10. So if you add your 290 plus your extra $1.10, that's going to give you $4. All right, last one for 10 distance travel 10 miles. All right, so the thing is 10 is equal to your 3 1/10 plus an extra 6 9/10. And 6 9/10, that's like saying 10 cents times, all right, so that's like saying 10 cents times 60, because 10 times 10 cents, that would be for like one hole, right? But we don't have one hole, we have six extra. So that's where the 60 comes from. But then we also have an extra 9/10. So we're going to multiply 9 times 10 cents. And that's going to give us a total of, that's 60 times 10 cents is 6. 9 times 10 cents is 90. And that's an extra 690. So we're adding 690 to what we already had, which was $4 in the table right there. So that's going to give you a total of 1090. Okay, now we're going to test if this is a proportional relationship. So first, we have 180 divided by 9/10. We're going to turn 9/10 into a decimal. So that's just going to be 0.9. And that's going to give us 2. All right, we're going to do the same thing for the next row. Let's see, 290 divided by 2. As you can see, you're not getting the same number. 145 is not the same as 2. So this is not a proportional relationship. The price in dollars is not proportional to the distance traveled. All right, next problem. All right, problem 3, a rabbit and a turtle are in a race. Is the relationship between the distance traveled and time proportional for either one? If so, write an equation that represents the relationship. So we're going to have to divide the time in minutes by the distance in meters for both the turtle, and we're going to do the same thing for the rabbit. Here we go. All right, just on this first one, you're going to get 0.0185. 185 are the repeating digits. Let's see if that is constant for the rest of the table for the turtle. All right, so far so good. Let's try the next one. All right, so as you can see, there's a constant pace for the tortoise. That makes sense. Slow and steady wins the race, as they say. So steady is another word for constant. So here's how we're going to write this. Let's use T for time, and let's use D for distance. So whatever's on the right side goes by itself. So we're going to say T is equal to, use your COP, and then that's multiplied by our distance. This is our equation right there. Now we're going to test for the tortoise, or for the rabbit. We're going to test for the rabbit now. All right, so if everything is equal to 0.00125, then the rabbit will also be running at a constant pace. I don't think that the rabbit will be, because I think the rabbit is going to gas out. Let's see. All right, and what you'll see in your calculator is 0.005, and the 5 keeps on repeating, and eventually you get a 6. What that means is that the calculator is just rounding. When you're getting like 0.00555555, like it's just the calculator's rounding at the end to a 6, but it's really just the 5's going to repeat forever. As you can see, the first and second rows are not the same. They're not equal, so it's not proportional, and there won't be an equation for the rabbit. Okay, problem number 4. For each table, what is the constant of proportionality? Guys, on this one, if they're asking you what the constant of proportionality is, we can assume that every row is going to follow the same rule. So just choose any row from your table, and it's going to give you the constant of proportionality. And that goes for all of your tables. So here we go. All right, I choose the first row. It's going to be the right side divided by the left side. So we're going to say 14 divided by 2. That gives me a COP of 7. Okay, we're going to, same thing for the other one. Doesn't matter which one I choose. I'll choose that one. Why not? So we're going to say 600 divided by 5. That gives me a COP of 120. All right, cool. All right, we're going to do the next row. It doesn't matter which row I choose, so I'm going to choose that one. Because whenever you divide by 10, you don't even need a calculator. You just move the decimal one space to the left. So I have 0.04. That's my constant of proportionality for table 3. And last but not least, I'm going to go with that top row. So that would be 10 over 4. And that's the same thing as 5 halves, which is equal to 2.5. So my constant of proportionality is 2.5 for that last table, and we are done.